Chapter 9, Lesson 7, Linear and Nonlinear Functions. All right, so a nonlinear function, not too difficult. It is a function that does not have a constant rate of change. Therefore, the graph is not a line. All right, it might be a curve, it might be a squiggly, but it's not a line. Okay, so if I want to look at graphs and decide if they are linear or nonlinear, I just look and see if it makes a line or not. So this graph right here is nonlinear. Nonlinear. This graph right here, nonlinear. This graph right here, linear. And this graph right here, nonlinear. Okay? Now, when I'm looking at an equation, and I want to decide if it's linear or nonlinear, here are some things that you can note that make an equation, that you don't even have to graph it, you don't have to find points. These are things that will make an equation produce a graph that is nonlinear. First of all, if your x is to a power other than 1, so in linear equations we might see y equals x plus 7. Well, the x is to the first power. But if the x is to a power other than 1, if it's squared or cubed or to the 4th power, 5th power, it's not going to be linear. Okay? The second thing is, kind of goes along with that, if it cannot be written as y equals mx plus b. So try to get it into slope-intercept form, and if you find that this is x squared or x cubed, then it's not a linear function. Okay? Another thing that also has to do with that is if x is in the denominator. So if you have 5 over x, and you have x in the denominator, it is not a linear function. Also, if x is an exponent, so if you have 5 to the x power, not linear. And then the last thing that you can look for is if x and y are in the same term, so if they're being multiplied together, you would have to divide by x to get the y by itself to be written in slope-intercept form, which means x would be in the denominator. All right, so let's look at some functions and decide if they are linear or nonlinear. So the first one, can I write that in the form of y equals mx plus b? Sure, I can move this 3x over here and have y equals negative 3x plus 7. And so I know that this is linear. Okay, y equals 2x squared. It's kind of in slope-intercept form, but I have x squared, so this one right here is nonlinear. Okay, y equals 1/5 x. Sure, right? Slope-intercept form, this is linear. Y equals 2 to the x power. X is an exponent, non-linear. Okay, 2x minus 7y equals 0. So again, can I get it in slope-intercept form? Well, if I subtract 2x, I have negative 7y equals 2x. If I divide by negative 7, I have y equals 2/7 x. Sure, that is linear. Now, if I'm looking at a table of values and I have some x and y values and I want to decide if it's linear or not, first thing I'm going to do is I'm going to check my x values and I'm going to see, are they increasing or decreasing at a constant rate? Okay, if they're not, and down here in number 2, I've already written this, if the x values are not increasing or decreasing at a constant rate, we can't even tell if it's linear or not because we can't check the y's and see if they're changing at the constant rate or not. So if they are increasing, the x's are increasing or decreasing at a constant rate, then check the y's and let's see how they're changing. And if they're both changing at a constant rate, it is a linear function. Let's look at an example to see what we're talking about here. So the first thing I want to do is check the x's. Well, how does it change here? Plus 1. How does it change from 2 to 3? Plus 1. How does it change here? Plus 1. If those are not changing at a constant rate, I can't make a decision if it's linear or not. If they are changing, then I want to check and say, okay, 1 to 4, it's changing plus 3. 4 to 9, plus 5. 9 to 6, minus 3. So my y's are not changing at a constant rate, so I say that it is non-linear. All right, let's check here. My x's, I have plus 2, 4 to 6 plus 2, 6 to 8 plus 2, 1 to 2 plus 1, 2 to 3 plus 1, 3 to 4 plus 1. This represents a linear function because when my x's have a pattern, my y's have a constant rate of change.